Welcome students. Today we are here to discuss about an experiment forward bias characteristic of a semiconductor diode. When the positive terminal of a battery is connected to P side of a diode and negative terminal of the battery connected to N side of a diode, then the diode is said to be forward biased. Diode offers low resistance during forward bias and current in the order of milliamperes. Cutting voltage is the characteristic voltage of the diode, after which the current increases sharply during this forward bias. This is the principle behind this experiment. In order to perform the experiments, the apparatus required are the variable battery, a milliammeter, a resistor, diode and voltmeter. So this is the variable battery. It has two terminals, positive and negative, and this knob to vary the voltage of the battery. So this is the instrument which is meant for microammeter as well as milliammeter, but in this experiment we want the milliammeter, the current in the order of milliampere. So we have to switch this knob towards 200 milliampere. So it has two terminals, positive and negative. This is the resistor, that is 220 ohm resistor, which we are using for this experiment. This is the diode. This is the diode. This terminal is P side, positive, and this terminal is N side or negative. This is the voltmeter. It has two terminals, positive, negative. The circuit connection is as follows. So from the positive terminal of the battery, a wire is connected to the positive of the milliammeter. The negative of the milliammeter is connected to one end of the resistor. Another end of the resistor is connected to the positive or P side of the diode. The negative side of the diode or the N side of the diode is connected to the negative terminal of the battery. From the P side of the diode, a wire is connected to the positive terminal of the voltmeter. And from the N side of the diode or the negative terminal of the diode, a wire is connected to the negative terminal of voltmeter, or the voltmeter is connected across the diode. The voltmeter is connected across the diode. Once the connection is over, switch on the power. Switch on the power. Now the power is on. So there is a knob in the battery. So keep at the minimum. Assume the current to be 0, so that the correspondence value in the voltmeter also is assumed to be 0. Now increase the knob in the battery such that adjust. Once the circuit connection is done, switch on the power. Initially, for 0 milliampere current, the voltage is taken to be 0 volt. With the help of the knob in the battery, the current is increased in small step. So for 1 milliampere, the corresponding value of voltage in voltmeter is 0.51 volt, which should be tabulated in the tabulation. Similarly, for 2 milliampere, the corresponding value of voltage in voltmeter is 0.55 volt. Likewise, the trials are done for 4 milliampere, 6 milliampere, 8 milliampere, 10 milliampere, 20 milliampere, 30 milliampere, 40 milliampere, till we arrive the constant value of voltage in the voltmeter. The intention of the experiment is to draw the IV characteristic curve and to find the cut-in voltage. According to the nature of the graph and with the help of tabulation, a graph is obtained by plotting current in y-axis and voltage in x-axis. In order to do this, we have to take a proper or suitable scale for x-axis values and y-axis values. Here I have taken x-axis, that is 1 centimeter is equal to 0.1 volt, and for y-axis 1 centimeter is equal to 2.5 milliampere. The values on x-axis are marked as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. The values on y-axis are marked as 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20, 22.5, 25, 27.5, 30, 32.5, 35, 37.5, 40, 42.5, 45. So these values are based on the scale chosen. For the first trial, that is for 0 current, the corresponding voltage is 0 and it is marked at the origin of the graph. For second trial, that is for 1 milliampere of current, corresponding voltage is 0.51 volt. 4 lines on y-axis constitute 1 milliampere and one line from point 1 constitute 0.51 volt. So their meeting point will be at this point. For third trial, that is for 2 milliampere of current, corresponding voltage is 0.55 volt. 8 lines on the y-axis constitute 2 milliampere and 5 lines from 0.5 constitute 0.55 volt, and their meeting point is at this point. Similarly, other trials have been marked in this format. Once the trials are marked, a freehand curve is drawn from the origin, passing through all the points. And this curve represents the IV characteristic curve. Then draw a tangent line on the curve to the x-axis. I have labeled this point as O and this point as P. OP is the tangent line drawn to this curve to x-axis. And the line meets the x-axis at 0.65 volt, and this reading is the cut-in voltage. The cut-in voltage of the given semiconductor diode is 0.65 volt. Thank you.